In this video, we will be answering exercises 1.1 of Mr. John Coburn's Precalculus textbook. I cannot assure you that we'll be answering all of the exercise problems there in the exercises 1.1, but I can assure you that we'll be focusing on the most, actually one of the hardest questions in that exercise chapter. So I would be answering most of them, I can assure you that, but as for the very last problems of this exercise, I'll be skipping those for you to answer by yourself. As for the reasons, well, I just simply can't for the time being. So let's start with number 93. So we'll be working with formulas. Relationships in a right triangle. So we are given H, M, and N, and their combinations based on what we have here. So given angle C is the right angle and H is the altitude of triangle ABC, then H, M, and N can all be expressed directly in terms of A, B, and C by the relationships shown here. Compute the value of H, M, and N for a right triangle with sides of 8, 15, and 17 centimeters. So I could derive based on what's stated here that we do have A, B, and C quantities. In order to work these combinations, we have to find first what A, B, and C are. So I think this poses as a clue. Right triangle with sides 8, 15, and 17. So probably this could be A, B, and C. How is it specifically A, B, or C? I'm not sure, but by default, I suppose that we say things from beginning to from start. Like usually in the alphabet, A, B, and C, they're in order. First, second, and third letters of the alphabet. So that's my assumption, but there could be other reasons why it might be A, B, and C for the values 8, 15, and 17 respectively. So yeah, C is 17. Alright, so now that we know A, B, and C, just encircle them like that. I just want to let you know, I want you to exercise to get used to how I write, how I label my annotations. When you see a gray encircle or something like that, it's not the final answer, but it's supplementary to our solutions that would lead to the actual final answer. So we need to compute for the value of H, M, and N based on the combinations we have here. So let's start with H. H is equal to A, which is 8, times B, which is 15, divided by C, which is 17. So 8 times 15 divided by 17, we get 120 over 17 centimeter, or in other words, it's 7.06 centimeters. This is the value of H. Let's move on to finding letter M. So M is equal to B raised to 2, which is, in other words, 15 raised to 2, divided by C, which is 17. So 15 raised to 2 is 225, divided by 17. In decimal form, the answer is 13.24 centimeters. I don't know what kind of answer your teacher would want you to, the form of your final answer would be. Could be either a fraction or a decimal. Whatever suits what your teacher wants for your answer to be, do it accordingly. So for letter N, A raised to 2, which is 8 raised to 2, divided by C is 17. So N, so 8 times 8 is 64, and put denominator as 17. Another answer could be 3.76 centimeters. Alright, so for number 94, I really did my attempt to answer it, but um, unfortunately I couldn't, so I'll leave that to you. Or either way, I'll be leaving that to other better mathematicians, those who have more scope over this lesson. Alright, so let's move to the applications. So as you can see, the titles in written in bold letter, those um, are, you could see the previous video, in the previous video that you basically talk about it. This is the video I promised that would focus on the practice problems in regards to that lesson. So if you haven't been to that video yet, or if you're still looking for general concepts in regards to this lesson, please do so. Please watch the previous video, the video before this one. Anyways, start with number 95, arc length. Arc length, the formula is S is equal to R theta, such that theta is expressed in radians, always, by default. Alright, the city of Pittsburgh, Pennsylvania, is directly north of West Palm Beach, Florida. Pittsburgh is at 40.3 degrees latitude, while West Palm Beach is 26.4. I won't be reading further. Basically, we have a radius of 3,960 miles. In order to find the value of theta, given these two degree values, so 40.3 degrees minus 26.4 degrees, we get 13.9 degrees. As I said earlier, and as stated in the previous video, in this formula, theta is expressed in radians. So we convert this value of degrees to radians. So from degrees, we get something like this. Degrees to radians, this is the formula. This is the fraction that we multiply our current quantity with. So in that sense, we get 13.9. I'm sorry. In radians, the answer is 139 over 1800 pi rad, or radians. This is our theta. Let's fill in the values. So S is equal to radius, which is 3,960 miles, times 139 over 1,800 pi radians. So with that, we get 1529 over 5 pi. Final answer in decimal is 960.7 miles. So how far apart are these two cities? 960.7 miles. That is the arc length. Alright, for number 96. Both Libreville, Gabon, and Jamame, Somalia, lie near the equator. So let's cut to the chase. In order to solve for theta, we subtract with a higher integer or higher value at first, and the next would be a smaller value. So 42.5 minus 9.3, it is hang on, it's 33.2 degrees, and you convert the degree value into radians, so you get something like this. And this is the actual value, so 83 over 450 pi radians. So again, the radius here in this word problem is not stated, but the concept, the idea of what's being talked about here is similar to what we have in number 95. We are measuring the distances between two places but one thing remains clear. One thing remains constant: the Earth's radius. Actually, this is I did some research, and um, the radius of the Earth is actually three in miles 3,960. This is an actual um, value, so you always keep that in mind. Radius is equal to, sorry, let me just write it um, by without abbreviation. So radius of Earth is equal to 3,960 miles. So with this in mind, uh, the same formula arc for arc length, um, S is equal to 3,960 me times 83 over 450 pi radians. So we put these values in the calculator. We get 2,294.619274. We'll just round this off to two significant units, or to the nearest hundreds, or just the two values. 2294.62 miles wide. So how wide is the continent of Africa at the equator? Approximately 2,294.62 miles wide. Alright, let's move on to the next problem. So area of the sector. A water sprinkler, so we get an angle of 40 degrees, a distance of 12 meters. I think we've answered this in the previous video, but let's re-answer it again. Just for the sake of the likely completion of this video, to make it quite organized in a certain sense. So radius is 12 meters, and our theta is 40 degrees, which is equal to so 40 degrees times, to express degrees in radians, from convert from degrees to radians, we get 2 over 9 pi radians. So this is our theta, 2 over 9 pi radians. Right, so we have the two basic, the two values that we need in order to find the area of a sector. So our formula is A is equal to 1/2 times r raised to 2 times theta. So A is equal to 1/2 times 12 raised to 2 times theta, which is 2 over 9 pi. So we put all these values in the calculator, and our answer is 16 pi. Or in decimal form, it is 50.27 meters squared. There we go. Let me just erase here for a while. Alright, let's move on to letter D. For letter B. I think I'm supposed to remove this formula, but anyways, let me just give this as a bonus for you. For letter B, we're trying to find the theta value, or the angle value, such that the area is twice as its current value, which is technically 100.53 meters squared. So I think we have everything that we need. The radius, I believe it's still the same. Yeah, the radius is still the same, of the same value. So area, which is 100.53, is equal to theta, the missing value, over 360 degrees times pi times 12 raised to 2. We multiply both sides with 360. So we get something like 36,191.14737, which is equal to 12 times 12 is 144 pi and theta. We cancel those, and yeah, we divide both sides this time with 144 pi so that we could cancel everything that's on the right side with theta. So theta will be alone, and basically the division of these two values, it would become 80 degrees. So this is the final answer. In terms of the unit, you might be asking, as the same question from the previous video that you might possibly ask. What should the unit be of the missing theta? By default, I think degree, the theta expressed in degrees, I think it's already good enough. But if there is a specific specification that you have to convert the final answer in either degrees or radians, specifically in radians, but please do so. It's just one step away, one step more than just leaving the answer as is, since you don't have to convert the value to anything else. Anyways, for letter C, let's move to letter C. This time we have the theta value and the area. The radius is missing. So area is equal to theta over 360 times pi times radius raised to 2. So area is 100.53 meter squared, but I don't really have to write the units anymore since it won't be really applicable to the calculator. So we have 40 over 360. We could actually never mind. I could show you a trick, but yeah, I don't think I could do it right now. Anyways, that's not really important. Times pi times radius raised to 2. Again, multiply both sides with 360 to leave nothing in the denominator, to remove any value that's not 1 or that could make a denominator not a denominator visibly. So we have 36,190.8 is equal to 40 pi r squared. Right. So we divide both sides with 40 pi. I'm quite surprised. We left so much space at the bottom. Let's just move it, adjust it a bit. Alright. So 40 degrees, cancel, and we have r raised to 2 is equal to 287.997. So we put a square root sign on both sides, and we get an answer of 16.97 meters. This is the final answer. Alright, let's continue. Number 98, still the same concept, area of a sector. So motion detector can detect movement 25 meters away, so any distance is obviously the radius already, unless something else, another value plays in place similar traits with what we have for radius, but right now we don't have that kind of situation. Through an angle of 75 degrees, so 75 degrees, convert that to radians. You get something like this, wherein theta is finally equal to 5 over 12 pi radians. Right, so for the area, formula is A is equal to 1/2 r raised to 2 pi, wherein, yeah, the area is actually missing. 1/2 times r raised to 2, which is 25 raised to 2, times 5 over 12 pi. So yeah, put these values in the calculator and we get the value of 3,125 over 24 pi, which is, in other words, 409.06 meters squared. So yeah. Alright, for letter B. So given that the area is 50% more, so from, hang on, 100% area is what? 409.06 meters squared, right? And 50% of area is basically this one divided by 2. So it's 204.53 meters squared. Now, logically speaking, 50% more area, so from its current, from the current value of 100% area, we just add 50%, so that makes 150%. Basically, finding the sum of these two values. So our new area for this situation is 613.59 meters squared. Alright, so this time the formula is something that we don't use to find the area of a sector. Instead, we find either the radius or the theta, either of the two elements that make us capable of finding the area of a sector. Hang on, I think this is, yeah, I'm pretty sure this is the formula. Alright, so A is equal to theta, which is missing, over 360. A is 613.59. There you go. Then times pi times radius raised to 2. Multiply both sides with 360. So cancel those. 360 times 615.59 is 220,892.4, which is equal to 25 raised to 2 times pi times theta. Alright, divide both sides with 25 raised to 2 theta. So we cancel. So theta is equal to 112.4995755. By the way, guys, I'm sorry if my voice is quite, or how I think right now is quite misleading sometimes. I'm trying my best not to like screw this up. I just wanted to deliver this to you, since I also have quite a strict schedule with my current situation. It's quite tiring. Anyways, letter C. So, given that theta is 75 degrees, range is missing, and to monitor 50% more area, technically we have the same area to use for letter C's situation, and we have to convert our theta in radians. Actually, no. No, no, no. We don't have to convert our theta in radians since this formula already assumes that theta is expressed in degrees, not radians. Not like unlike this one that focuses in the sense that theta is rad. Well, this one theta is deg. Gets? So I have to get a connection. Alright, so these are the two values. Let's put them at the actual formula. So 75 over 360 times pi times radius raised to 2. Oh, multiply 360 on both sides. Cancel. We get, hang on. Yeah, 220,892.4 is equal to 75 pi r raised to 2. Yeah. Alright. Divide both sides with 75 pi. So, doesn't fit. Wait. Okay. R raised to 2 is equal to, put these values in the calculator and you get 937.4964627. Put a square root symbol on both sides. R is equal to 30.61856402, or in other words, if you round it off, it's 30.62 meters. This is our radius. Okay, let's move. Before we move on to number 99, we have to recall that this is what I actually said earlier. Formula for finding the area of a sector. Theta is expressed in rad or radians, wherein the other formula that's used to find either the theta value or the radius, given that we have an area that's either default in value or is modified based on the specific instructions, regardless of what happens or whatever is given, theta will always be expressed in degrees or deg. Okay, number 99. This is now, from then onwards, we'll be applying what we know about the formulas of angular and linear velocity as well as their conversion factors. Things that you have to be quite familiar already. Okay, for the angular velocity, W is equal to theta over time. So before that though, let's read you'll have to read this. Basically, the radius is 56 inches, as seen here, and the roundabout is turning at 3 over 4 revolutions per second. So 3 over 4 rev per second. Alright, these are the given. So I think these are enough to find the angular velocity. Angular velocity is 3 over 4 times revolution. If you're not sure yet about how I'm writing, what I'm actually writing right now as solution, please do use the previous video as reference. There, I might have already explained step by step and justified in a necessary way how I solve for angular velocity, linear velocity, and how I convert the current values to its desired value in a different unit, in a desirable unit. Okay, um, our t is seconds or per sec, since it says here rev per sec. If it's rev per minute, then the time will be 1 minute, but that's not the case right now. So 3 over 4 revolution over 1 sec, it's 3 over 4 times 2t over 1 second, which is we cancel 2 and 4, so we get 3 over 2 pi. So we can just turn this into decimal form. 1.5 pi rad over 1 second. This is the final answer of the angular velocity. Right, for finding the linear velocity in miles per hour, linear velocity is v is equal to rw. So in linear velocity is radius. What's our radius? 56 inches. I've also mentioned about this in the previous video, that in every radius value there is always an invisible denominator of 1 rad. So whatever value you have in radius as a numerator, so in this case 56 inches, there will always be per 1 rad. I think it's an important detail. Maybe it's not, but I think it is. If you think it's not, then it's your decision already. Just wanna, but the thing is, I just want to tell you that I was sort of successful knowing this, even though the concept is quite difficult and varying. Every problem has its own unique way to solve it. There's not much standardization. You'll get by just by listening to what I'm saying right now. So times w is our angular velocity, which is this one. So times 1.5 pi rad over 1 second. Right, let's move it here. Currently, our value is in inches per second. Our desired unit is miles per hour. So, yeah, it doesn't fit. I need to bring this down over here. Okay. So we have inches to miles. 1 mile. So 1 mile is equal to how many inches? 63360 inches. I did not derive this from anything. I just memorized. I just know that 1 mile is 63360 inches. Okay, so we have secured the elimination of inches and the introduction of the unit miles. Let's do for seconds. So 1 hour is equal to how many seconds? 3,600. So we eliminate the previous units. Let's make them history. So rad, we have mile per hour. So put all the values we have left in the scientific calculator, and we have something we call I'm sorry, wait. riding a roundabout. Yeah. Something that's not exactly equal, but in approximation, the answer is 15 miles per hour. That is the linear velocity. Right. Let's move to 100. Carnival rides. So radius of 12 feet. And spinning rate of 35 RPM or revolutions per minute. So as for the angular velocity, W is equal to theta over time. Theta is 1, I'm sorry, it's 35 revolution over time, which is 1 minute. So 35 times 2 pi over 1 minute, or 70 pi rad over 1 minute. This is the final answer. This is the angular velocity in radians. So just in case you're wondering, why does it have to be said that your answer should be in radians when automatically your answer is already in radians? That's just a head start. If the given says that you have to put your answer in degrees, then you know what to do. Convert the current value into degrees given, specifically 180 degrees over pi. Multiply this with this if you want your answer in degrees. But yeah, that's not the case. Just want to know the possibilities and the tendencies. So for linear velocity, we need to have it in miles per hour. So velocity is equal to RW. Velocity is equal to, what's our radius? 12 feet. So 12 times this one, W, or the angular velocity, is actually, wait, I think we have to label the units. For radius, we have 12 feet over 1 rad. Every radius has an over 1 rad value as their denominator. For the angular velocity, let's just copy paste it. There you go. So what's next? From feet to minutes, we get miles per hour. So for feet, 1 mile is 5,280 feet. How did I say that? Technically, 1 mile is equal to 6,360 inches. We divide this with 2. This is the answer, 5,280. You might want to think about it. Why is it 12? Well, 1 feet is 12 inches. So I hope that makes sense. Anyways, now that we have secured the elimination of feet and the introduction of mile, we could now try to eliminate hour. So 1 hour is 60 minutes. Eliminate. Eliminate. Alright, let's put the values in the scientific calculator. Our answer is 29.99 miles per hour. Right. Let's move to 101. Speed of a winch. So the radius is 3 inches, while the turning point is 20 revolutions per minute. Right, for angular velocity, it's theta over t, 20 times revolution over 1 minute. So 20 times 2 pi over 1 minute, we get 40 pi rad over 1 minute. So yeah, I think this is the angular velocity. This is the final answer. Let's find B, linear velocity. So V is equal to RW. V is equal to radius, which is 3 inches. Then put over 1 rad. Then times the linear velocity, which is this one. There you go. Times, hang on. Alright, so currently our answer is in inches per minute converted to feet per second. So 1 inch, I'm sorry, 1 feet is 12 inches. Then for minute, 1 minute is 60 seconds. So cancel, cancel, cancel. Put these values in the scientific calculator, and we get 1 over 6 pi, which is 0.5235987756. V is equal to 0.52 feet per second. Okay, so letter C, time is missing. So it asks here, by the way, this is also a question answered in the previous video. If you want the full explanation, then feel free to watch the previous one. This is just going to be quite faster, since yeah, it's not every time that everything will be slow. Anyways, time distance is equal to 6 feet, so we know what our velocity is. It's this one, 0.52 feet per second. Let me just duplicate that real quick and put it here. There we go. Oops. There you go. Distance is 6 feet. So T is equal to D over V. T is equal to 6 over 0.52, which is equal to 11.54 seconds. This is the final answer. Okay, let's move on to 102. Speed of a current. Actually, wait. It's pretty long already. I need a break. Yeah, we'll be finishing at 107. Yeah. I think this is going to be part 1. The video is quite long, and yeah, I'll just make a part 2 about this. I'm pretty tired now. Anyways, thank you for watching. Thank you for understanding. I'll see you in the next video.